All right, welcome. Today we're going to pull back the curtain and decode the language of electronics. This is really a guide for managers, for leaders, anyone who wants to confidently steer a tech project without necessarily being an engineer themselves. It's all about having better, smarter conversations with your teams.
So let's start with a big question, one you've probably asked yourself. How does a great idea, that spark of genius you have, actually become a real, physical smart device you can hold in your hand? Well, it turns out it all comes down to understanding a few basic building blocks.
Okay, so here's how we're going to tackle this. First, we'll cover the alphabet of electronics. Then, we'll talk about powering your idea, controlling the electrical flow, and how you can sketch out circuits. After that, we'll get into giving your circuit a brain, and finally, we'll put it all together, from components to concepts.
All right, first up, the alphabet of electronics. We're talking about the fundamental building blocks here.
Okay, on to part 2, powering your idea. I mean, it's pretty obvious, right? Nothing happens without power. This is always the starting point. So let's talk about voltage. What is it really? The easiest way to think about it is as pressure. Imagine the push coming from a battery or any power source. It's that initial force, that oomph, that gets everything moving. Okay, so if voltage is the push, what's it pushing? It's pushing the current, simple as that. Current is the actual flow of electricity moving through the circuit. You can't have one without the other. No push, no flow. No voltage, no current. This is where it all clicks into place with a super simple analogy. Think about a garden hose. The pressure of the water sitting in the pipe, ready to go, that's your voltage. And when you open the nozzle, the amount of water that's actually flowing out, that's your current. Pressure and flow, voltage and current. See? It makes perfect sense. All right, part 3, controlling the electrical flow. So we've got power flowing, which is great, but raw, uncontrolled power, that's not just useless. It can be really dangerous for our electronics. We've got to tame it. And our first tool for taming that flow is the resistor. The name kind of gives it away, right? It resists the current. If we go back to our garden hose, a resistor is like pinching the hose a little bit. You're making it harder for the water to get through, which reduces the flow. This is absolutely essential for protecting delicate parts of a circuit from getting fried by too much current. Next up is the voltage regulator. Now, this component is like a personal bodyguard for the most important parts of your device. See, power from a battery can sometimes spike or dip, but the sensitive stuff, like the circuit's brain, needs a super stable, predictable amount of voltage. The regulator's job is to stand guard and make sure that no matter what's happening at the source, the output is always perfectly steady. It's a non-negotiable safety feature. Okay, section 4, a sketchpad for circuits. We've got the basics of power and control down, but how do your engineers actually test an idea without spending a ton of time and money on a permanent version? This is where rapid prototyping comes in. And this is their sketchpad. It's called a breadboard. It's literally a board with a bunch of tiny holes. You can just plug your components right in, connect them, and build a temporary circuit in minutes. Nothing is permanent, there's no soldering involved. If it doesn't work, no big deal. You just unplug the parts and rearrange them. It's all about trying things out fast. So if the breadboard is the sketchpad, what are the pencils? Well, they're these things. Jumper wires. They're just simple, flexible wires with little pins on the ends. You use them to connect all the different components on your breadboard. You're basically drawing the lines of your circuit. Moving on to section 5, giving your circuit a brain. Okay, so far we've built a body. It has power, it has structure, but it can't think. It can't make decisions. To make our device smart, we need to give it a brain. So how does this brain actually think? Well, it thinks in 2 basic ways, digital and analog. Digital is super simple. It's either on or off, yes or no, 1 or 0. Just like a regular light switch, it's either on or it's off. There's no in between. But analog is different. It's a whole range of values. Think of a dimmer switch for that same light. You can have it at 10% brightness, 75%, or anywhere along that smooth spectrum. That's analog. And this brain does 2 fundamental things. It takes information in and it sends commands out. We call this input and output. The easiest way to remember this is input is reading. The brain reads information from the outside world, maybe from a sensor that's checking the room temperature, and output is writing. After it reads that temperature, it makes a decision and writes a command, like turn on the air conditioner.
So it reads, it thinks, and it writes. That's the core loop.
All right, our final section, from components to concepts. We've looked at all the individual letters of the alphabet. Now let's see how they spell out the whole story.
So here's the entire journey in a nutshell. First, you power it up. You start with something like a battery. Second, you control that power, using things like resistors and regulators to keep it safe. Third, you build a quick prototype, using a breadboard and some jumper wires to sketch it out. And finally, number 4, you add the brain, a microcontroller, and tell it what to do.
And this is the really cool part. These simple pieces we've just talked about, they're not just for little science fair projects. This is the alphabet of everything. The very same principles are at work inside your smartphone, your smartwatch, the thermostat on your wall. All of it is built from this fundamental language.
Look, the idea here was never to turn you into an electrical engineer overnight. Not at all. It's about giving you the language, the alphabet, so you can have more meaningful conversations, ask better questions, and really understand what's going on with your tech projects. So now that you know the alphabet, what new conversations are you going to start?